Alright, this is lesson 8 for 7th grade, and today we're talking fractions and percents. And it's pretty basic to start off once again, and as we go on, things will get a little bit more difficult, but we need a little intro into all this. So, first things first, fractions and percents are commonly used to name parts of a whole or parts of a group. For instance, if we just thought of pizza or pie, what is shaded here, one of the 4 pieces are shaded right there, so the part would be 1 out of the whole 4. So 1 out of 4, and if we want to change that into a percent, the whole circle also represents 100% of the circle, and we may divide 100% by 4 to find the percent of the circle that's shaded. So that's what they do, they take their 100% divided by 4, and we also see that 1/4 of our circle is also 25% of our circle. So that means the rest of our circle that is not shaded would have to be 75% or 3/4, because we have to add up to 1 or 100%. Alright, with fractions at the very basic level, the denominator, that is how many equal parts there are, and that's the bottom number in a fraction. And the numerator is how many parts, well, it's above, and it's how many parts, well, we're focused on. So in this case, numerator 1 out of a total 4 equal parts. Okay. So 25% means 25 out of 100. Basically, all percents are out of 100%. The most you can have is 100% in most cases. Especially when we're talking grades and things like that. Unless we get into extra credit, then you can get more than 100%. In a lot of cases, even if you look at like, I take a daily vitamin, and if you look on the label, there are some things on there where, I don't know, like B12 or something like that, where it's 200% of your daily value or something like that. So you can be above 100%, but in most cases, or in all cases, we are out of 100%, and usually we're talking about 0 to 100%. But if we have a mixed number, such as 2 and 3/4, we can represent that with the circles that like we did before, and this would be more than 100% because it's more than 1. So this actually means 2 plus 3/4, and if we do circles, we'd have 2 full circles, and then 3/4 of a circle shaded. So that's 2 and 3/4. As a percent, that is 275%. So, how would we write 3 and 1/4 as a percent? Well, that's going to be 300. And we found out earlier that 1/4 is 25%. 325%. So, those are your above 100% percents. Alright, let's take a look at one of these. Alright, name the shaded part of the circle as a fraction and as a percent. So here we go. We have 5 equal parts, so that's our denominator. And 2 of them are shaded. So 2 out of 5, that's our fraction. Now in order to turn this into a percent, we have a couple options. Option 1, we can go ahead and do 2 divided by 5 and then multiply that answer by 100. So 5, 2, put a decimal there. I know that 5 will not go into 2, that can't happen, but 5 can go into 20. And that can happen. Make sure we bring our decimal up. 5 can go into 20 4 times. 4 times 5. Do our subtraction, we get 0, 0, 0. Okay. So 0.4, that's our decimal. 0.4 is the same thing as 2/5 as a decimal. But we're talking percent, so we have to multiply that by 100. You could put that on your calculator if you want, but when you multiply by 100, it's just moving your decimal over 2 spots. So this is 40%. So that's one way to do it. Option 2, we can see how many times 5 goes into 100 and then multiply by 2. So that would be 5 and 100. 5 goes into 10 twice. Times 10, subtract 0, 0, and 5 goes in there 0 times. So 5 goes into 120 times, and then we multiply that by our numerator, 2 times 20. And we still get 40%. So whichever way you want is fine with me. You should get the same answer either way. Alright, we did go over this one quickly too. Which of the following could describe the part of this rectangle that is shaded? Well, this part's shaded, and it looks like it's over 50% or half, so it can't be A, and it can't be B, because 40% is less than 1/2. So we would go with C, because it's a little bit more than half, so 60% about. Okay, oops. Mixed numbers can be represented on the number line, and it's very key to notice what we're counting by. So 7, 8, 9, yes, but we have a number in between 7 and 9, so we know we have a decimal and a mixed number. So we have to figure out how many segments there are between two whole numbers. Looks like we have 1, 2, 3, 4, 5. So we go 1, 2, 3, 4, 5. We have, we're going by fifths, 8 and 2 out of our 5 possible segments. Oops. Erase that there. 8 and 2 fifths. Okay? Now obviously if our dot was here, we could say 8 and 5 over 5, but that's the same thing as 9 anyways, so we would just write 9. So that's why that 5 is above our segment over 9. Alright. But yes, 8 and 2 fifths is where A is. Yes, and once again to point out, important to focus on the number of segments in between two whole numbers, and not on the number of tick marks. Alright, this is where we've seen things like this before. This is a ruler blown up so that this is 1 inch, and most rulers go by 1/16 of an inch, so 1/16, 1/8, 3/16, 1/4, all the way up to an inch, and that's just for accuracy purposes. Why are measurements on rulers approximations? Well, the first thing we need to know is, what is an approximation? Well, that is not an exact answer. You're approximating. So it's kind of like a good estimate. And this depends on two big things. Number one, the quality of the measurement. There's going to be some error between each person that actually measures something. So I could have 5 students measure the same segment, but they could be off by just a little bit amount and get a little bit different answers for each thing. So quality of the measurement, that's why it's an approximation, and the precision of the measuring tool, and I'll show you an example of that. If we were to guess how long CD was, we would have to kind of ballpark it. We'd have a harder time measuring what CD is, or estimating, or even this segment. We'd have a hard time kind of estimating exactly what we thought each of those was. But if we get a better measuring tool, like this one, it's split into more segments, it's a lot more clear to see what these are. So this would have been 2 and 3/4 about, this would have been 3 and 1/4 about. So the measuring tool and the quality of the measurement. Alright. We did not do any measuring with rulers. They've done that in the past, and I didn't have enough rulers to go around, so we didn't do any of this, but... okay. Arranging from least to greatest. Now, the students need to understand the concept of common denominators in order to do this. What we need to do is find a common denominator between all of these. Our denominator is the bottom one, remember? 2, 4, 8, 16. Well, once we get that common denominator, we can see which fractions are bigger than the others. So, 2, 4, 8, and 16, they're all factors of 16, so that's what we're going to go with here. So I'll take 1/2 and 1/4 and 5/8. This one's going to stay the same. It already has a denominator of 16. So 1/2, to get to 16, we have to multiply by 8. I'm going to check my time real quick. Okay, we're looking good. So we're going to multiply by 8 over 8, and we will get 1 times 8 and 2 times 8, 16. So that's 1/2 with a denominator of 16. To get this one to 16, 4 goes into 16 4 times, multiply by 4 over 4. And what you can see that we're doing is we're not changing the fraction at all, because we're actually multiplying by 1 each time. 8 over 8 is 1, we're just giving it a different denominator. 4 over 4 is 1. And whenever you multiply by 1, we learned this in our one of our first lessons, it doesn't change anything. You can multiply by 1, it's the multiplicative identity, it doesn't change anything. Alright, so 1 times 4, 4 over 16, and 8, we're going to multiply by 2 over 2, and we get 5 times 2 is 10, and 8 times 2 is 16. Alright, and then we also had 7 over 16, hanging out over there. So, now we can order these from least to greatest. Smallest one will be 4 out of 16. So here's our 1 to 1/4. Our next one, 7 out of 16, 2. Next one, 8 out of 16, 3. And our last one, 10 out of 16, 4. So the correct order, 1/4, 7 over 16, 1/2, and 5 out of 8. That is our correct order there. So, common denominator is an important thing there. Alright, that is the basis of what we talked about today, and we will see you next time.